So this video is going to have us take a look at acid-base equilibrium. And in order to do that, we need to start by examining water. So this organizer is in your binder, obviously in the acid-base unit, so make sure you find this pages. We're going to take a look at both sides. But like I said, we're going to start with the equilibrium of water. So acids and bases neutralize each other. We've learned that already, and to produce water. And it's the water part that we need to take a look at. So most water stays together. Most water, if you have a beaker of water, it's mostly H2O. However, a small number of water molecules will naturally ionize and form H pluses and OH minuses. So if we were to write the dissociation equation, so here's the balanced equation. So we got H2O liquid forming equilibrium between H plus and OH minus. So what would we do to write the dissociation, or that is the dissociation equation, what would we do to write the equilibrium constant for water? H2O is a liquid, these guys are aqueous, so the constant, which we call Kw, is going to be equal to just the product of the products. The reactant is a liquid, so it's not included. So Kw is equal to H plus times OH minus. And remember that, I didn't introduce you to this, Kw is actually 1 times 10 to the negative 14. That's the value for Kw. So very small number lets us know that we don't have a whole lot of these around. But if we do have pure water, and we do have some of those around, what is the concentration? How much H plus and OH minus do I have? Well, if you think about it, if each of these are x squared is equal to 1 times 10 to the negative 14, so x is equal to the square root of 1 times 10 to the negative 14, which is 1 times 10 to the negative 7. So look at that, 1 times 10 to the negative 7, and pure water has a pH of what? 7, you say? All right, so there's a relationship. We'll get to that in a few minutes. But I want to make sure you guys are comfortable with this first equation. So we've got 4 equations that we're going to see. The first one is Kw is equal to H plus times OH minus, and that's 1 times 10 to the negative 14. So in pure water, they're going to equal each other. But if you have an acid or a base, that's not true. If you have an acid or a base, the pH is not equal, but we can still use Kw to get there because the two of them in solution have to still multiply out to be 1 times 10 to the negative 14. So for example, here we've got this one. If H plus is 6.4 times 10 to the negative 8, what's Kw going to be? Well, Kw, or not what's Kw, what's OH minus going to be? Kw divided by H plus is going to equal your OH minus concentration. So 1 times 10 to the negative 14 divided by 6.4 times 10 to the negative 8. Oops, I don't have these calculated out. I'm going to have to pull out the calculator and do this quick. So 1 to the negative 14 divided by 6.4 to the negative 8 is not the right answer. Try that again. 1 to the negative 14 divided by 6.4 to the negative 8 is equal to 1.56 times 10 to the negative 7. Okay, so H plus is 6.4 times 10 to the negative 8. OH minus is 1.56 times 10 to the negative 7, or 1.6 times 10 to the negative 7. So, do we have an acidic or a basic solution? How are you going to figure that out? OH minus and H plus should be equal if it's neutral. Which do I have more of? More OH minus. 10 to the negative 7 is greater than 10 to the negative 8, so this is actually going to be a basic solution. Another way that you can check yourself, the exponents are going to have to add up. So if you multiply these two numbers together, what you get in your calculator is 10 times 10 to the negative 15, which is the same as 1 times 10 to the negative 14. So if you want to do a quick check, exponents should add up to negative 15. Numbers should multiply out to give you 10. That's one way you can do a quick check for yourself. I got a couple checks coming further on down as well. Okay, so one more. If OH minus is 9.2 times 10 to the negative third, what's H plus? So once again, you're going to use KW to get your H plus. 1 times 10 to the negative 14 divided by 9.2 times 10 to the negative third. You should get 2.38 times 10 to the negative 4. So once again, which one's in bigger concentration? That's not right, because those exponents don't add up to 14. So let me try that again. Oh, I did the answer again. So what the heck? Give me one moment here. There. No, that's not. What the heck? Negative 14 divided by 9.2. Okay, let's try that again. 1.1 times 10 to the negative 12. That's better. 13 and 12, or 3 and 12 add up to 15, so that's good. All right, so H plus is 1 times 10 to the negative 12. OH minus is 9.2 times 10 to the negative third. Which one do I have more of? Got more OH minus, so once again, this is a base. So hopefully you can see that as the amount of H plus gets bigger, the amount of OH minus gets smaller because they have to multiply out to give you this number. So as this exponent gets bigger, that exponent gets smaller, and so forth. All right, so there's equation number 1. KW is equal to 1 times 10 to the negative 14 is equal to H plus times OH minus. So if you have the H plus concentration, you can very easily get the OH minus concentration. Next equation is now that you know how to get the H plus and the OH minus concentration, let's get to pH. Okay, so pH actually stands for the power of the hydrogen ion, or POH stands for the power of the hydroxide ion. You could also have something like the PNA, which is the power of the sodium ion. So the P just really is standing for power. That's all that means. So I could have the P of anything. For H plus, we want to know what the power of the hydrogen ion is. Well, here's how it's going to work. If H plus is 1 times 10 to the negative third, pH winds up being 3. If H plus is 1 times 10 to the negative 7, pH is 7. Hopefully you know that from up here. If if H plus is 1 times 10 to the negative 10, pH is 10. What kind of pattern do you see? Likewise, if I go to OH minus, 10 to the negative third OH minus is the same as a POH of 3. OH minus 10 to the negative 7, POH of 7. OH minus 1 times 10 to the negative 10, POH of 10. So what are we doing? The power of the hydrogen ion literally stands for the exponential power. So this exponent of the concentration becomes the basis for the pH value. Now, not everything's going to be nice and pretty, like 1 times 10 to the whatever. So we've got to have an equation that lets us get there. So here's the actual numerical equation, or the algebraic equation for pH. pH is equal to the negative log of the hydrogen ion concentration, or POH is equal to the negative log of the hydroxide ion concentration. So in both cases, we're taking the concentration and converting it to a p-value, kind of like I could do up here. So the PNA is really equal to the concentration of Na, or the negative log of the concentration of Na plus. So how do you do that on your calculator? Well, most of you are using Inspire, so take a look at the side on the left. If you have an 84, the key code is a little bit different, but if you have an Inspire, this is what you're going to do. You hit the plus minus key because that takes care of the negative. You're going to hit the control 10 to the x key because that takes care of the log. You're going to see this come out, log with 2x. Don't worry about this guy. That's going to default to the 10th power, or to the base 10. So what you only have to do is put in whatever the concentration is into that square. So this this is where you want to put your number. Don't worry about that guy. Okay, and then you're going to plug in your concentration value. So give it a shot. Practice with these two for me. So if the H plus concentration is 8.3 times 10 to the negative 4, what is the pH value? So negative log of the concentration. And I just put it in my calculator wrong. 8.3, sorry, I'm being a little inept today. Did it again, negative 4. So I have essentially 3.1, 3.08 for the first one. How about the second one? 7.2 times 10 to the negative 9 gives you 8.14. Okay, here's another trick. If the concentration is to the negative 4, the p-value is going to be 3 something. If the concentration is to the negative 9, the p-value is going to be 8 something. So the pH is always going to be 1 digit less than whatever the exponent of the concentration is. So that's another way that you can check yourself. So now you've got 2 ways to double check and make sure you haven't put something into the calculator wrong, which is how I knew that I've messed stuff up, because the answer didn't make sense with what I had. All right, so there's equation number 2. You have to know how to put it into the calculator, but I will provide you with this equation. So you just have to know what the key step is to put it into your calculator. Okay? All right, there is a backside. However, I am going to pause this. I'm running out of time for this video clip, so I'm going to pause it and go to part 2. So if you would,